Hello, everybody. My name's Simon Prickett, and this is From Documents to Dialogue. It's a web stream where I'm going to be talking about how to get data out of PDF files and into a smart chatbot using CrateDB and some AI and a few other things. So what we're going to do is I will go ahead and share the desktop here. And let's get rid of the title bar there. And if you're also, this is a live event. So if you are watching either on YouTube or LinkedIn, drop us a comment and I can actually see those and I can also respond to them. So for example, we got a comment from Prashant here who says hi. And also Susie's looking forward to this. We have somebody in Austria as well who's on LinkedIn. So we can see we're live streaming to both platforms. So let's get started. I'm Simon Prickett. I work in developer relations at CrateDB. My background is largely technical training, software architecture, IoT projects. I like to build a lot of stuff with JavaScript, Python, but also C and other languages. I enjoy working with databases because generally there's a lot of different problems you can solve with them. And the one we're going to look at today is quite an interesting one because it involves some unstructured data, it involves different types of searching, and it also involves the ability to use AI to sort of understand the user's intent and also generate an appropriate response to a query based on some context that's in the database. So what are we going to use today? I thought I'd make this look a bit like a recipe. So we've got some ingredients. We're going to take some PDF files. So PDF files contain different sorts of data. There's text in there. There can be tables in there, which can also contain text. And there can be images. And we're going to look at how to extract data from this sort of locked in island of goodness and put it into a database so that we can search it, answer people's questions, and then point them back at the original document. So the original document and the original page in that document, and tell them whether supporting resources that help answer their query are contained in text or images. So we're going to do that. We're going to build a chatbot, and we are going to have a user who will ask the chatbot questions. So we've got humans, one of our ingredients. And then we're going to use the database for that. We're using CrateDB today because this is a CrateDB live stream. And also because I wanted to show you CrateDB's ability to do what's called hybrid search. So we're going to mix and match a sort of traditional keyword type search, extract important words from the user's query and look for matches in the database with them. And we're going to combine that with vector similarity or semantic search. So compare the output of an embedding model with an embedding generated from the user's query and find documents where those two vectors are quite similar. So semantically, as opposed to just sort of more blunt keyword matching. And there's reasons why you might do both of these things. So we're going to combine them and get the best of both approaches. Now, this project is something that uses Python to glue everything together. And we're using a few libraries. We're using OpenAI's models for both generating embeddings and also generating chat responses. And we're using some other Python libraries that I'll cover when we get to them for extracting data from PDFs and also for figuring out keywords in a user's query. But before we go any further into what we're doing here, let's switch to the browser. And this is the end result. So what we're going to do today is go through how we got to this result. And I'm also going to share the GitHub repository for you. So if I move to this tab, we've got a GitHub repository here. I will put the URL for this in the chat. In fact, I'll do that right now. So GitHub for this project is there. So I'll put that in the chat. And I've also got a handy banner that we can show here. So don't worry about copying that down right now. It'll be in the chat. You can find it later. But the aim is that you'll gain an understanding during this stream of how to build this chatbot, how to use CrateDB with it, and then you can clone the repository. We've put a couple of our own white papers in there as examples, but you can swap in your own PDF files and change some of the configuration settings and basically play around with it and see what insights you can get from your own document data. So let's take that away right now. And let's dive in and ask this thing a question. So this has been given a couple of PDF files that are CrateDB white papers. So it's essentially got a knowledge base about some CrateDB stuff. There's nothing in the code that knows anything about a particular domain. So if you wanted to have, say you got a set of PDFs that were recipes or something like that for different sorts of food, you could totally put those in there and make a chatbot for that. Or you got manuals for, say, industrial machines or something else that you wanted to have a chat about. Have a mechanic ask what is going on with a certain machine and get some responses from the PDFs without having to read them all. You can totally do that. So if you've got a source of PDFs that you want to try out with, I really encourage you to try this out. But let's get on and ask it a question. So what's a good way to organize JSON data in CrateDB used with an AI chatbot? Now that looks a little bit small, so let's make that a little bit bigger, which might mean that we get some scrolling going on, but everyone can see what's going on. So if I ask it here, what it's going and doing is actually doing a couple of searches on my query, and it's also turning my query into a format that can be used with the database. So let's just zoom around a little bit. So we asked this, what's a good way to organize JSON data in CrateDB for use with an AI chatbot? And we got a response back that is in plain English and it's quite chatty. And where did it get this information from? Well, what we did was something called retrieval augmented generation. So we've retrieved documents that might help with the answering of this query. We've augmented a prompt to a ChatGPT model in this case, so an OpenAI model that generates chat responses. And we've told it to cite its sources in that. So here you can see it's come back with telling us about organizing JSON in a relational database, and CrateDB's got a distributed architecture. And then it's told us, oh, for more information, refer to relevant sections in the architecture document. And you can see it actually gave us hits in both documents and what type of hit they are. So it found something relevant in the text on page 24. And then this is a sort of confidence score that it has relative to other documents, which comes from the searching. And if we click through one of these, then what we should expect to see is we load up the document and it opens at the page with the right, the context that the user wants. So generally, we've got a chatbot here that does all of those things. There's two parts of a pipeline to create this. There's the ingestion that stores all of the data from the PDFs in the database. And then there's the loop of the sort of chat response. So what we're going to do with the rest of the live stream is kind of take each one of those steps to pieces and work through how it works. Again, if you want to try this out yourself on your own PDFs, the link is in the chat, and I will put it back up again here for a second. So you can go there, grab this. You can use one of our free cloud databases as your data source. And basically, it's just Python. So pip install, follow the instructions, put some PDFs in a folder, and you'll have a chatbot. Right, so back to here. Let's continue our story. So this is an overview of what CrateDB is. Normally on a live stream, I would spend a little longer introducing CrateDB, but what you need to know from this is CrateDB is a database for all different types of data. They can all be accessed through SQL. So everything we're going to do today with the database is SQL. And what we're going to do is basically sort of run a path through this diagram that shows we're going to take some unstructured input, so PDF files, and we're going to turn that into embeddings, which is not a database thing. That's going to happen with some OpenAI models and Python code. Once we've got those embeddings, we're going to save them in CrateDB along with the original text. And we're going to save them in a way that allows us to do full text search and then also vector similarity search. Then finally, we're going to actually use that, again through writing SQL queries, to augment a prompt that is going to go to a smart chatbot. So we're going to send a prompt and supporting data that matches database, vector similarity, and keyword hybrid searches to the chatbot. The chatbot's going to generate the response in natural language, and then we're going to show that to the user. And that's kind of our chatbot loop. We're going to use a process called retrieval augmented generation, or RAG. We're actually going to use something slightly better than that. So the R in RAG is retrieval, so we need to search for relevant data. So here it says we're going to do similarity search in a vector database, so we're going to do that in CrateDB. But we're also in the same database, in fact, in the same table in the same database, going to do sort of keyword search. So what you might know as BM25 search, so best match keyword searching. CrateDB uses Lucene for this, and we're going to combine that with KNN nearest neighbor vector similarity search to get results. And then we're going to take those results, normalize the scores, and present them to the user. So we'll get matches that match on keyword, and we'll get matches that match semantically. And we'll take the strongest versions of those, combine them, and hopefully get a stronger result for the user. The A in RAG, augmentation, is we're going to then use that data to augment a prompt that we are going to send to an AI model. So rather than just asking a sort of ChatGPT type thing, what do you know about organizing data in CrateDB from its training data, we're going to use private data from these PDFs to enhance that by supplying that as part of the prompt. And say, refer to your sources, use these sources. Then finally, we're going to use the LLM to generate an output. So the chatty part of what you get back, that sort of natural plain English response, that's going to come from the LLM. So here we've got some PDFs. This is one of the PDFs that we've got. The two that are in the sample data set that come with this project are both CrateDB white papers. So there's two sorts of data in here, as we said earlier. There's textual data, so stuff that's literally text inside the PDF. A couple of paragraphs there, examples of that. And then there's image data. So these embedded images in here also have some level of value. So if we can figure out how to get a description of what's in the image, then we can also add that to the database and perform searches over that. So we can have people understand what this image actually means, what concepts it's talking about, so that the chatbot can present it as a valid result to a user query that also talks about those themes. So we've got a mix of text and images. And we're going to show some Python throughout this. Why did we write this in Python? Well, largely because there's ease of availability of libraries for doing some of the things that we needed to do outside of the database. But you could do this in other languages. So here we're using a library called PyMu-PDF. And what we're doing is essentially opening the PDF file, and then it's able to decode it. We are iterating through the PDF file, and we're looking at it at a page level. So on each page, what we're going to start by doing is taking the first line and the last line on the page. These might be headers and footers. They might be low value items in terms of what the value of a search is. It might just be the page number and some copyright stuff and the name of the document at the top. So we're essentially going to look for those. And if we see those over and over again, we're not going to take them forwards into the database. Then down here, the sort of main part of what we're going to do with text here is this is a loop that loops over every page inside the PDF document. What it's going to do is use PyMu PDF to get the text out of that. Provides a nice interface where we can just literally call get text and get the text on the page. And then we're going to perform some level of cleaning on it, just remove some new lines and that sort of stuff, and put it through a chunking process that I'm not going to go into the details of here. But basically, the chunking process ensures that on each page, we pull a chunk of text that looks like it's about a coherent thing, so a paragraph or whatever, and also that it's long enough. So here, for example, that section in the top left might be considered one chunk. When you're generating vectors and performing keyword searches on these things, and you're working at a chunk level here, one of the variables that can control the quality of the response that you get is going to be your chunk size. So fewer chunks will be larger, might talk about more topics. Shorter chunks will be obviously talking about less things, but you might then miss a match that talks about this thing and another thing. So chunk size is a variable here that you can play with, and might depend on what's a good chunk size, might depend on what your data looks like to start with. So the approach we're taking is going through the PDF file, iterating over each page using library code, and getting the data out as chunks, as text. And what do we do with that text? Well, we're going to do a couple of things. We want to do vector similarity search on it. So we want to generate some embeddings for that. So what does embeddings mean? It's essentially a long array of floats that describe the text and the concepts in the text. And that's done by an embedding model. So here we're using OpenAI's text embedding 3 small model, and we just call their API and tell it, here's the text of the chunk that we want embeddings for, and we get back something that looks like this. It'll be a very long stream of numbers. It's meaningful to OpenAI, but it can also be compared in CrateDB to other vectors that were created with that model. So what we'll do later is use this approach to create embeddings of the query or the question that the user wants to ask, and then use CrateDB's nearest neighbor search to say, okay, which chunks are nearest to this query? So that's one approach for text. The other thing that we need to get out of the PDFs here is images. And what we want to do is somehow figure out what the image is talking about. So we're actually going to do that with some AI again. So here with, again, PyMu PDF stuff, we can go through each image in the code. So here's an image. We can go through each image in a loop that looks like this. We can get the bytes of the image, so binary representation of it. Then what we're going to do is also grab the text that is near the image to give the AI some extra context about how the image was located in the page, what it was near, what it was next to. And then we're going to generate an image embedding. And how does that work? Well, what we're going to do is, again, call an OpenAI model with their API to do that. Here we need a model that can understand an image as an input. So we're using GPT-4 Turbo. And we're giving it a brief prompt. You are an expert at describing images in detail. Provide rich and concise descriptions of the key visual elements of any image. And then we're giving it the bytes of the image. So it will receive the image, and we're essentially saying to it, can you describe this image textually for us? And what happens when we do that is you get something like this. So over there on the left, we've got an image in the PDF. On the right, we have got the text that comes back. And what we're going to do with that text is a couple of things. We're going to store it in CrateDB so it can be full text searched with the keyword method. And we're then going to also generate the embeddings for that so we can do a vector similarity search. So imagine this is now just like some text, but the original source was an image. So we'll remember that we got it from an image, we'll generate the embedding for it and save it in the database. So now we've got embeddings, we've got the original text chunks, so the plain English things that we pulled out of the PDF. We've got the textual descriptions of the images with the context around those. And we know which document, page, and so forth those came from. So how do we store that in CrateDB? Well, CrateDB is a SQL database. It's also a NoSQL database because NoSQL means not only SQL, not don't use SQL. So we use SQL for everything. So here we're creating a table, and what's inside the table is some columns. We're going to store the document name and the page number and the content type, whether it was originally text or image in the PDF. Then we're going to store the actual chunk of content itself as text. We're going to use a full text analyzer for that. And we're going to say it was in English. CrateDB supports other languages, and it uses Lucene for this. We're going to say our contents text was in English. So we're going to store the text version of the chunk there. And then we're going to store the embedding version as a float vector data type. And the 1536 there is essentially the number of floating point numbers, which is the size that the OpenAI model returns. So in one table, we've got everything describing a chunk of content, including two representations for the hybrid search. We can do the float vector search with KNN, and we can use full text search with BM25. How do we put this into the table once we've got this data from Python? Well, again, CrateDB SQL database. So what we're going to do is run an insert statement that looks like this. Nothing scary. It's a fairly regular insert statement. And then we're going to call some code that executes a CrateDB query. Now, there's a couple of ways you can talk to CrateDB. So CrateDB is Postgres Wire Protocol compatible. So if you've got a client that talks Postgres Wire Protocol, for example, in Python, we support a SQL Alchemy dialect, then you can use that. It also has an HTTP post protocol. So in order to keep the dependencies down and keep this code super simple and easy for people to follow, we've elected to use the HTTP interface here. So we get things into CrateDB by literally just posting them into a URL. And we provide our SQL statement as the data body. And we authenticate using basic authentication, so username and a hash of the password. And that is it. That will put all of our data in CrateDB. So we insert one chunk's worth of data, one row into our table, and then we can start doing things with it once we've been through this process for every chunk in every PDF. Here's what it looks like when we're done. We can run SQL queries against this. This is just the CrateDB admin interface, but you can see down the bottom there that we've now got a table which stores, what was the original name of the document. That's going to be useful for when we want to provide a link to the document in a chat response. What page number was it on? That will also be useful because we can deep link into that. And then whether the content was text or an image. We've got a textual representation of the content there that we're going to use for keyword matching search and also to provide to the AI for context for the response. And if we scroll over, we've got the embeddings. So the really, really long stream of, I think it was 1,536 floating point numbers. We got all of those. So everything's in the one table here. It's called PDF data, and we can just run normal SQL queries on it. So here I'm basically selecting everything that was text on page 3 of the CrateDB architecture guide. So that kind of finishes ingest. I mean, obviously, there's a little bit more subtleties to it than that. We have to write code that opens the PDF files and provides them to PyMu PDF. But that's sort of not interesting in terms of what the actual process is. So what I tried to show was how we take the PDFs apart and get the data out. If you want to see the mechanics of opening the files and all of that stuff, then go grab the repository on GitHub, and I will share the URL again for that, but it's already in the chat. So ingestion over, we've got everything in a database. That's great, but how do we get this person here to talk to a chatbot in a natural way and get natural responses back when all of our data is in a SQL database? So what needs to happen at some point is we need to take the user's query, try and understand it, fire off appropriate SQL queries into CrateDB, get results, and pass those results to something that can generate a response. So we're going to spend a little bit of time looking at how that works. So what we think the workflow looks like should be the user asks the bot a question, the bot responds. It's somehow all-knowing. It's able to respond and speak English or French or German or whatever language the user chooses to talk to it in. And on the face of it, that's the entire workflow. But there's obviously a lot going on inside the bot there. So what's really happening is the first thing is the user's typed a query. The query is going to be in plain, I'll say plain English, but I really mean plain natural language, whichever language you're choosing. And that query needs to be turned into a format or formats where we can understand it and do some database searches on it. So we're going to do two things with it. We're going to turn it into embeddings so that we can do the vector similarity search. And we're also going to perform some basic keyword extraction on the query so we can perform a keyword search. And we'll see how we do both of those with Python. And again, we're using OpenAI for the AI aspects here. So what actually happens to the user's query is we're going to run it through the text embedding model to get the embeddings for it. We're also going to get the actual key most meaningful words out of the phrase using another Python library that we'll have a look at later on in the code. And once we've got both of those, so we've got an embedding for the query or a vector for the query, and we've got the keywords for the query, we're going to run some SQL statements against CrateDB that say, hey, do a keyword match on that PDF data table and find chunks whose content match this keyword, and also find chunks where the vectors are similar to the query vector. So we're going to do two sorts of search, but the mechanic's the same for both. It's SQL statements. Again, we'll look at that as we go along. And then when we get something back from that, that's still not going to be in a form that the user can directly understand. It's going to be rows response from a database. So it's going to be rows and columns. Here's things that match. Here's relevant scores. So what we then need to do is feed that into another OpenAI model. And this is the augmentation part of RAG. We're going to prompt the model to answer the question and give it the question, but also give it the context of all the chunks that matched. So everything that came back from the database, we'll give it the text, we'll give it the document name, we'll tell it whether it was in an image or not, and tell it use this context when you're generating your response. So it will generate the response, which then goes back to the bot code, and then the bot speaks, or as we saw on the web, pushes out that response in plain language back to the user. So there's a little bit more to this workflow than there originally looks like. It's not the person having a conversation with a bot and the bot is seemingly all-knowing based on its training data. The point of RAG here is we're augmenting that with additional data. And the point of a hybrid search is we're doing two sorts of search over that data to get decent results. So we're doing the vector and the keyword. So backing that up a little bit, let's start with the user's query. So how do we extract keywords from the user's query so that we can do the keyword search on it first? Well, there's a Python library called Basi that's really handy for understanding language. It's an NLP library. And what you'll see in this example fragment I've got here is we can get keywords out of a given piece of text or a given string by asking Spacey to tokenize things. And we're asking it for things that are nouns, proper nouns, or verbs. So things that make good keyword search triggers. And then if we ask it a question like, how can I leverage CrateDB to build an intelligent chatbot powered by unstructured data contained in PDF files, you'll see that it's decided to condense that down to a stream of keywords that we can then use in a BM25 search. So we're going to match on leverage, build, chatbot, powered data contained in PDF and files. Maybe unstructured would also have been a good thing to have in here. But the approach we're taking here is just to reduce or boil down the user's query into literally keywords that we're then going to use for a match. And that's one sort of search that we're going to perform here. How do we do that search in CrateDB? Well, I've said a couple of times already, we do everything in SQL. So it's another SQL query. We are going to do a select query that looks like this. And we're going to use what's called a match predicate and say, I want things in the content column in the table. So that's the text of our chunks from the PDF, to match the keywords that we're providing that we got from Spacey from the user's query. And what's going to happen there is we'll run that query in the same way as before. We'll post it into the HTTP endpoint in Crate and we'll get a document back again. And what you'll see is the document that we get back is an array of results, and each result represents a row in the database. So here are some matches that we got, and what we get back is the ID of the chunk. So that's a combination of some of the other fields. We get the name of the PDF, the page number, whether it was text or an image. So you see here we have a text one, and we get the actual text as well, and then a confidence score. And then for an image, similar thing, because even though the original content was an image, we derived the text from it with the image model earlier when we put things into the database. So we are able to search it with the same mechanic because we've got a textual description of the image and we know that it's an image on page 7. So this result can then be referred back to that when the user is presented with a list of results. So this is one set of results using one mechanic. So this is using the keyword search mechanic. How do we then use the vector similarity KNN search to get a second aspect to this search? So, we've done a keyword search. We want to do a semantic search as well. Well, it's basically the same approach as when we generated the embeddings for a chunk of PDF file that is now in the database. We need to take the user's query, so the sentence they wrote. We need to generate embeddings based on it. And then we need to perform a vector similarity search in CrateDB with that embedding, so that long series of numbers. So here's how we create that. That's nothing particularly special. It's just OpenAI's API. And then here's how we do the other sort of search in CrateDB, which again is a SQL statement. So again, recurring theme here, everything's a SQL statement, and you're probably familiar with writing SQL. So here we're going to select some things from the PDF data table again, but now we're going to use a KNN match predicate, so nearest neighbor match. And what we're going to do is say, I want things where the vector stored in a column named content embedding, which is where we put those embeddings when we ingested the PDFs. So each chunk has an embedding. And I'm going to compare that to the vector of the user's query that we just generated. And I'm going to return how many results, maximum. And again, I want them ordered by the confidence score. Same mechanic for getting the results. We get a document back, and it's an array of arrays where each array is a row. So here we've got exactly the same sort of result, even though the search mechanic was entirely different. So we've normalized the result format between the keyword search and the vector search. which makes them easy to combine going forwards. So now we've got everything, all of our results back. I've actually skipped over a step here. So there is a step for normalizing those results. So we have two sets of results, and we have the KNN results, the vector ones, and we have the keyword results. And we have some code that just mashes them together and normalizes the confidence scores. And that's kind of some maths that's not particularly relevant to this live stream, but you can look at it in the code if you want to. And again, I'll pop the code repo up. So I assume at this point, we've got one normalized set of results that might have come through a keyword match or a vector similarity match. It doesn't actually matter anymore, because what we want to do is generate an answer. And what we want to do is have an LLM generate the answer for us, so it's in sort of written natural language. And we want it to use additional context over and above its training data. So those results we're passing in as context in the prompt here. So you can see there's a context section. And here's the actual prompt. It's just telling it what to do. And we're telling it to refer to things in the context. And we'll see why that's important in a minute. So there's the context, which will be all of the things that match our search. And then the question here that we've asked it to answer is the user's original question. So the one that they typed that we used as the basis for the keyword search and the vector similarity search. And again, all we're going to do to get this is use OpenAI's API. So we can use, in this case, ChatGPT 3.5 Turbo. And we're just going to say, I'm prompting you with this document, go away and generate a response. And when we get the response back, we're just going to send it out to the user. So in this case, when the user asks something like, how can I store JSON data in CrateDB and query it with a chatbot interface? All of that stuff we saw in the previous diagram happens. So we take this, we run it through Spacey to get the keywords. We do a keyword search in CrateDB. We generate embedding for it with OpenAI's embedding model. We run a KNN nearest neighbor search in CrateDB against that embedding. We get two sets of results back, combine them, send it to the GPT LLM model. And what comes back is something that looks like this. So an English language, natural language response that talks about what the LLM found based on the documents that we provided to it. And then we asked it to link its sources. So we've got the sources that we've parsed out of its response. And then in the front end, I've just made a nice ability to have those links through. So you can click through to the, you can click through to page 17 of the CrateDB architecture guide there. So now that we know all of that, what we can do is go back to the chatbot here, and we can ask it another question. So let's try and make this a little bit bigger while I'm asking it a question. So let's ask it something like, show me a diagram that describes how CrateDB fits into a RAG workflow. So something relevant to this screen. And what happens now when I hit enter on this is, we know that what's going to happen is we're going to extract the keywords from this query. We're going to create an embedding of it. We're going to do a search for the keywords using one type of search predicate in CrateDB. And we're going to do a search with the embeddings using another type of search predicate. Then we're going to combine those results, send it to the LLM, and generate and show the results that are generated, and slightly manipulate them so we get some links. So off it goes. It's doing all of that in however long that was, not very long at all. And we should get back. I'll zoom out again. So interestingly, the LLM's not perfect. It thinks RAG stands for red, amber, green workflow, but it said we can find a diagram illustrating how CrateDB fits into such a workflow on page 10 of the architecture guide. And if we click through, it's slightly wrong. Sometimes it doesn't always get it right. So it's not actually found as a diagram, but it's found some text. So what we would expect to see if it had found a diagram would be an image result here. And when we click through, we go to the image. But let's ask it some other questions and see. So show me a diagram of a typical CrateDB architecture. See what it wants to do with that. No, all text again. Okay, so of course this was working and doing that when we tried it earlier. But you can trust me, there are image responses in here, and it's the same mechanic. So we're using the value of the description of the image that an AI produced originally, storing it as a chunk in the database, and then searching over that and remembering it was originally an image when it comes back. So let's give it one more go. What are some data types supported by CrateDB? See what it thinks about that. No, it's sticking with the text matches, but you get the idea. It will go through and talk to us about what it's found. And you can see here, we've gone through and it talks about data storage. And in here, this is going to talk about what the way that the different data types are stored. So that, I think, was about everything that I had. So that's kind of a bit of a whirlwind tour in the time that we had available, so 45 minutes, of building a RAG chatbot. There are a number of variables in this. So if you want to play with this yourself, and I encourage you to do that, then go to the GitHub link at the bottom, grab a copy of this, and what we've got is, let me switch back to the browser so this is interactive. What we've got in here is the two parts of the Python project. So there's a data extractor for ingesting data into the database. These are both really well documented, so you'll be able to follow the instructions and get things up and running. Really, the only dependencies are Python and a CrateDB database that you can get for free in the cloud. And the chatbot folder in here has the chatbot code. It's also got a couple of PDFs in here that are used as the source data. But like I said at the start, it knows nothing about this source data. So if you've got your own or your company's PDFs and you want to substitute those in there and try this out yourself, I would recommend doing that, because then you've got something that is domain specific to you really easily. There's some other parameters that you can play around with in here. So you need to bring your own, let's make that a bit bigger. You need to bring your own OpenAI key, as you might expect. You need a CrateDB instance. You can get that for free in the cloud. And you can configure which models we're using, including for Spacey, so for pulling out keywords, but also for OpenAI. And you can configure and play around with the parameters to the AI, which will change the quality of response that you get. You can also change the, it's not configurable in here just yet. It's in the code. But if you go into the data extractor, and somewhere in here, there is some code that basically has a minimum chunk size. Where is it? Here we go. So it looks for things that are bigger than 50. You could play around with the logic here to change the chunk size and see how that goes. And this is something that we're hoping to do as a workshop. So you could learn how this mechanic works, get it up and running on your own machine, and play around with some of the parameters. So I would totally encourage you to try it out yourself. And if you are really interested in CrateDB and learning some more stuff, including how to do keyword searches and vector similarity search, Then we have some free courses online. You can go to CrateDB Academy, and somewhere there's a banner for that. There we go. Take a free course, and you can get a certificate of completion that shows that you completed the course and passed our multiple choice exam, and you can share that on LinkedIn. So that was the end of my slide deck. I'm just going to take a moment to look at the comments. So will this be available as a video on the channel? Yes, absolutely. Immediately after this finishes, give or take some level of YouTube processing time, this will be available at the same URL on YouTube that you are on now. It will also have the link to the GitHub repository in there, and I will also update the GitHub repository to link back to the video. So if you get the code, you'll get the live stream, and you can use them both together. So there we go. Other than that, thank you very much for coming today. That was a fairly whirlwind live stream of quite a complicated topic, so a lot of moving parts, but hopefully you got an idea of, if you break one of these things down into its constituent parts, it's relatively easy to chain them all together and build something that is quite an interesting end-to-end pipeline. But also, if you have other uses for any of these parts, we split out the data extraction from the chatbot, so you could look at just the bits that are relevant to you. If you want to keep in touch with me or ask any questions about this content or anything else, we also have an online discourse community, so forums, and you can join that at community.cratedb.com. But that is all for today, I think. Yep, we don't have any more comments. So I will wrap it up here, and I'll see you next time. Thanks, everybody. Bye.